Alright, this video is 6.4, Part C. Third video in a series for the fundamental theorem of calculus. It says, suppose g of x equals the integral from 0 to x of cosine of t dt. What is g prime of x? Well, before we do that, it says evaluate the right side of the equation. So, the integral of cosine is sine, so it would be sine of x from 0 to x. Well, actually, I need a different variable somewhere. That's sine of t from 0 to x. So that's going to be sine of x minus sine of 0 if I evaluate my limits of integration. Sine of 0 is 0, so that equals sine of x. Now it's asked me to take the derivative of it. Well, what's the derivative of sine of x? If g of x is sine of x, then g prime of x is cosine of x. Notice that it's the same, except for you fill in an x. Now, what if we change the limit of integration? It says, first, how is this problem different than the first one? Well, there's a negative 2 instead of a 0. Evaluate the right side of the equation. Well, it'd be the same thing. It's going to be sine of x, except for it's from negative 2 to x. Why do I keep writing x instead of a t? It's a t. So that'd be sine of x minus sine of negative 2. Take the derivative of that. Well, if g of x is sine of x minus sine of negative 2, when I take the derivative of that, the derivative of sine is cosine. The derivative of sine of negative 2 is 0, so plus 0. So it's just cosine of x, because that's a constant. I got the same thing again. Did changing the lower limit from 0 to negative 2 matter? No, because the derivative of a constant is 0. No derivative, 0. Okay, example 12. It says, suppose g of x equals the integral of a to the x of cosine t, where a represents any constant. What's the derivative? Well, basically, this is the bottom line. If you take the derivative of an integral, you just fill this in. Okay? Suppose g of x equals x to the a, where a represents any constant. What is g prime of x? Well, let's actually work this one out. It'll be sine from, and I have a knock at my door, so we'll come back to this video in a minute.